Hello everyone, I am Anshika Singh and welcome to the series where we try and build intuition around mathematical concepts in under 10 minutes. Today's topic is decimal expansion of rational number. So first question is, what is rational number? The numbers of the form p by q, where p and q are integers and q is not equal to 0, are rational numbers, right? Every rational number can be represented as decimal numbers as well. This is decimal representation of the rational numbers. So how is it achieved? We simply divide p by q and the question is the decimal expansion. While doing so, two cases can arise. After finite number of steps, the division terminates as the remainder becomes 0. But in the second case, it might be possible that instead of terminating, the remainder never becomes 0. In the quotient, a string of numbers just keep on repeating itself. We call it recurring decimal or non-terminating recurring decimal. So, a number whose decimal expansion is either terminating or non-terminating recurring is a rational number. For example, 0.25. This is nothing but 1 by 4, right? So, the rational number we are talking about is 1 by 4. See that p and q both are positive integers and q is not equal to 0. So, when we divide 1 by 4, we get 0.25. See that while division, it gets terminated, that is at one point remainder becomes 0, so we get the final answer as 0.25. we do not need to further keep the division process going. While let us take another example of 2 by 3. Okay, what do we get as a result? We get 0.66666666 and so on. We can just keep on dividing keep on dividing further and further. It will never end. When does a division end? When the remainder becomes 0. So in this case, the remainder will never become 0. So we have to stop at certain point. So what do? We are just going to find out the string of integers which are repeating itself again and again in the decimal representation. So here we have 0.6666. You can see that 6 is the only number which is repeating itself infinite times, right? So we are going to represent it as 0.6 and put a bar over this 6. Okay, this bar represents which or how many number or the string of numbers which is repeating itself in the decimal expansion. Decimal expansion is terminating only when the prime factors of q are 2 and 5. In cases of non-terminating recurring, look at the repeated numbers of the decimal places. The length of this repeated string is called as the length of its period. If we go back to our example 0.6666, here the digit 6 is repeating itself. The length of its period becomes 1. Let us just practice some of the questions now in order to understand. On the screen you can see the long division of 5 divided by 32. Decimal expansion is 0.15625. So you can see that it is terminating. Without the division you could have found out. See that we have to see that the prime factors of the divisor consist of either 2 or 5. And we have 32. 32 has the prime factor of 2. So it was going to terminate at some point. I will perform further of the examples and you can see how it proceeds on the screen. So that's it about decimal expansion of rational numbers. Do let me know how did you like it. Thank you.